Good morning, everyone. Welcome to the Scott Institute for Energy Innovation's first webinar as a part of a series entitled Energy Resilience and COVID-19, Pivoting in 2020. My name is Anna Siefken. I'm the Executive Director of the Scott Institute for Energy Innovation. We have a couple of slides at the beginning, but before we do, I'd like to welcome Jay Whitaker to say a couple of words, and then we'll dive right into our conversation. Jay?
Thanks, Anna. Welcome, everybody. I'm not sure how many are on, but it's many tens of people. We're really excited to have you here. This is the first one of these we've done, as Anna just mentioned, and we're trying things out. So our ask is that you please give feedback any way you can. We'll likely send something out to get your direct feedback, but any other way you can reach out to us, please do as well. It'd be great to hear as much as you're willing to tell us about. This came about as we're looking around the world, especially amongst energy institutes and folks doing research on energy. People are looking at the nexus between the COVID-19, dominant thing that's occurring in the world right now and how it's impacting energy resilience and other things that are happening. So we're doing our part to bring together these concepts, these phenomena, and understand the relationship and how to move forward. And so this is the first effort in this, and we really hope that we can do this incrementally better each time. And we want to do a lot of these. People are at home. They have hopefully a bit more time to spend and schedule these kinds of events, and we really would like to, maintain our connection with you. So Anna has organized all of this. She's done a great job. The team has done a great job at the Scott Institute, and I am really happy to see it coming together. And I just wanted to greet you all as well, and I'll hand it back to Anna. Thank you very much.
Thanks, Jay. So as I mentioned, we're going to be talking today about the impacts on the energy industry and how robotics can improve energy resilience in a time of crisis. We want to say a special thank you to our two guests today. This came together in a deep conversation with RE2 Robotics about how energy can impact in a time of crisis, as I mentioned. So COVID-19 has sharply highlighted the importance of safe and reliable energy systems to keep essential businesses and hospitals operational in times of need. Robotic technology may be key to improving key resilience in the face of crisis. So today we've got two thought leaders that are going to talk about it with us. Before I get to introductions, I'm going to do a couple of slides here. The first is to just let you know that we are the Scott Institute. So we serve as a hub for energy information and research partnerships at Carnegie Mellon University. So our goal is to move towards a sustainable low carbon energy future. And we're very excited to bring this partnership together. So today, as I mentioned, this is our topic. This is the first in a series of webinars like this that we'll be doing. And we do have our guests today. I'm going to quickly go through their introductions. I'm going to tell you a little bit about each of our guests. And then I am going to let them talk for a few minutes apiece. We've received a lot of questions. We've tried to integrate those into our talking points today, just to make sure we hit a lot of those. We are working on the technology, making sure that we can see when you raise your hand. I know that some people have already raised their hands. We have some questions that are coming in. We're going to try to get to all of those as best we can. We've currently set this for 45 minutes. I think we can go a little bit longer if needed, but just wanted to make sure you were aware of some of those housekeeping issues. Also, before I get started, I definitely want to thank all of those that are on the front line. Obviously, the line workers, the folks that are working in hospitals. We understand that this is a really, really difficult time for a lot of people, and we think that it's important to be thinking about resilience in a time like this. So thank you again for joining us. So without further ado, I want to introduce our two guests, and I think I'm going to go off of this share mode so that you can see us a little bit better. So with us today, we have Josh Gould. Josh is the Director of Innovation at Duquesne Light Company, where he leads the company's Innovation Center, identifies and maintains a portfolio of innovation opportunities, and serves as the principal liaison with external parties focused on innovation. So prior to joining Duquesne Light in late 2019, so he's a new arrival here in Pittsburgh, Josh founded and led an innovation department at Con Edison, which is the utility for the greater New York City area. So obviously has a lot of experience to lend to our region. Previously, he worked at the Department of Energy's Moonshot Agency, which is called ARPA-E. Many of us are very familiar with that, which funded energy research and startups ultimately backed by investors like Bill Gates. So thank you, Josh. We also have with us today Travis Schneider, who's the Business Development Manager at RE² Robotics. So he is responsible for commercial market development at RE² Robotics. In this role, his primary focus is to examine key market verticals to determine opportunities for robotics collaboration with partner organizations like Carnegie Mellon. So Mr. Schneider has a decade of professional experience creating business-to-business partnerships and opportunities applying either automation or robotics within a variety of high-tech markets. So thank you again to our guests. Josh, I want to send it over to you first to talk a little bit about some of the COVID-19 related things that Duquesne Light is doing. Obviously, we have a lot of questions about that. I wanted to make sure that you were able to speak to that first.
Yeah, absolutely. I'll just a couple brief comments about that, and then we can shift to the kind of robotic topics at hand. First and foremost, the health and safety of our customers, the health and safety of the public and our communities, and the health and safety of our employees is paramount at this time. So we've taken a lot of steps to enable that safety. We've enacted social distancing throughout the organization. A lot of our employees are working remotely. We have a PPE policy, includes face masks, and wherever possible, our crews in the field are operating in a socially distant fashion. And so for those of you in Pittsburgh and in the region, just a little kind of PSA here. If you do see our crews in the field, definitely give them a thumbs up, give them a wave, but please do maintain your social distance with them. They're working hard to prioritize the continued safe and reliable function of some of our community's critical facilities, things like hospitals. And we know a lot of people in our community are suffering at this time. We've enacted a wide variety of policies that try to help support our customers. We've got a moratorium on shutoffs, expanded payment assistance, and waiving late fees. And I think just the thing I'd add here is I think it's natural in a time of crisis for people and organizations to tend to look inward. But I think what we've seen now with this pandemic, the need to innovate in order to better serve our customers and communities, not only has it not lessened in the wake of the pandemic, I think it's only grown. And so that's why Duquesne as a whole and our innovation team specifically, we remain engaged in innovation to try to serve our customers and our community. It's also why it's so important that we participate in discussions like these. So thanks to Anna, thanks to our partners at Carnegie Mellon and RE². We're thrilled to participate in this webinar today. And we believe we'll have a role to play in community recovery and development moving forward, and looking to innovate in a variety of areas. It's not only about technology, looking for new programs and offerings as well, but obviously innovation around robotics is a great area of interest, given the strengths of our local community, companies like RE² and certainly Carnegie Mellon around robotics. So thanks again for having me. Thrilled to be here, and looking forward to the discussion today.
Great. So Travis, do you want to tell us a little bit about some of the work that you're doing and how it's relevant to these important topics?
Yeah, thanks, Anna, and thanks for the opportunity. So a little bit of background about RE² before we get started here today. So RE², as Anna had mentioned, is a Carnegie Mellon spinoff. Might be no surprise that we're a Pittsburgh-based robotics company, really specializing in mobile outdoor robotic manipulation. That is, we produce robotic systems that physically interact with the world to perform some meaningful task. We're a team of about 60 world-class roboticists and engineers from all walks of life. Regardless if you're talking about electrical engineering, software engineering, or mechanical engineering. And locally, we design, develop, and produce robotic systems which can either be teleoperated or kind of remote controlled, or perform tasks fully autonomously. And really, as a whole, RE² has been really focused on its primary goal of developing groundbreaking robotic technology that can save lives and improve quality of life. So RE² has been a leading developer of human-like robotic technology that's been deployed throughout the globe to help warfighters performing explosive ordnance disposal operations. So since 2001, we've really been working to help our warfighters render improvised explosive devices safe without having to expose soldiers to that threat. And as a company now, we're looking at how else we might be able to leverage this life-saving technology, and where else, what other industries might benefit. The energy industry obviously being one of them. So thanks again for including me in the discussion, and I'm looking forward to it.
So Travis, this audience, which is growing by the minute, thank you all so much for being here, is pretty well versed in energy, because a lot of the folks that we reach out to for events like this are very, very versed in energy, but maybe not in robotics. So how would you sort of categorize some of the areas where you could have the biggest impact?
Yeah, that's a great question, and it's probably a great place to start the conversation today. I know sometimes robotics can be an intimidating topic for those who might not be directly in the field. But classically, when you kind of boil down robotics, they can be lumped into one of three categories. First, they can move through the world. Examples of that would be like autonomous vehicles. There's a number of companies locally right within Pittsburgh that are working on developing that technology. Second, they can perceive the world. Some examples of that might be things like drone technology that are deploying cameras or sensors to be able to inspect devices where people might not be able to gain access. And third, and often the most challenging, is robotics can interact with the world. A very classic example is probably a robotic system that you could imagine being deployed in more or less an automotive application, where they're picking and placing parts or maybe performing some welding operation. So more or less robotics that are physically manipulating objects or interacting with the world. So those are really the three categories that you can kind of boil robotics into.
Okay, so I guess they're not really new. Obviously, we know about robots that have been used within the industry for years, including all the way back to 3 Mile Island. Can you tell us more about how technologies have evolved and some areas of particular focus for your company and other robotics companies?
Yeah, that's correct. In fact, currently the robotics industry within just energy is estimated to be about a $500 million market. And while certain technologies might be newer to the energy industry, drone technology in particular has really taken off, maybe pun intended, to support a lot of inspection work, where line workers have had to otherwise walk the power lines to perform physical inspection. Now they can leverage a lot of advancements in drone technology to support that task. I think it's also important to note that locally there is a number of companies producing these types of technologies that support, either systems that fly or crawl to inspect critical infrastructure. And what's interesting about drone technology too is it's evolved out of really defense programs. So commercial drone technology didn't actually exist before the year 2013, but ever since then, ever since kind of penetrating the commercial space, it's really evolved by making those more manual technologies like infrared cameras and integrating them into drones such that operators could perform line inspections in a much faster process.
So then, obviously, safety and reliability are two important areas. So maybe we could talk about those just for a few minutes. So obviously there could be huge impacts for those. Josh, I mean, how are you all thinking about that?
Yeah, I think it's a great place to start as far as safety. A variety of applications you could think of there. Even if you just take the area of kind of storm response, what we do in terms of responding to a storm. Sometimes those storms knock down pieces of infrastructure. You can imagine down power lines. We'll have to send someone out to make sure the public stays away. It's clearly a public safety hazard in the event that happens. And you could easily imagine a robotic solution to help augment the employee and help the customer stay safe, stay away from that hazard. You could imagine inspections of critical infrastructure. And again, if you take the kind of storm angle there, might you be able to send a robotic solution out towards the end of a storm or maybe even during a storm before you can send a human crew safely out to do that. And so, I think a lot of really interesting examples around safety, and I think that's a great place to start.
Yeah, and I would add one more comment to that. speaking to the reliability aspects that robotics hold the promise of really performing these tasks with greater consistency and applying torques or forces. I mean, these types of actions can be digitally controlled. So by applying that type of control in work practices, work can be performed much more consistently and may actually contribute to improved asset longevity. So also helping to improve the reliability aspects of typical.
Well, so it sounds like safety is an important aspect. Obviously, reliability, we're keeping people out of harm's way at a utility. So what are some of the challenges that we're having? Why haven't we moved forward on this? Why isn't, where are we?
Yeah, it's a great question. And I think any business, whether it's a utility or any kind of business, we always need to start with what our customers want. And the first thing, and rightly so, that our customers expect of us, and you see this nowadays in particular, is the provision of safe and reliable power. That's where we start as a utility, and that's what customers rightly expect of us. And so just, to put it very simply, any robotics application that we deploy in a real life operational setting, just full stop, has to work. It has to work. And that doesn't mean we can't deploy anything, but I think there are good reasons for some of the caution in deploying solutions. And again, it really goes back to what our customers expect of us. I do think there's ways we can address this. So, I think there's a lot of opportunity and potential creativity in thinking about how do we pilot some of these solutions in environments that might replicate operational conditions, aren't of course operational to start with, but replicate operational conditions. So we feel like once we deploy them, we have a pretty high degree of certainty that they are indeed going to work. And then the other thing I just briefly mentioned that I think is a positive and a real opportunity for our industry is, the electric grid doesn't look radically different here in Pittsburgh than, say, Ohio. And so a lot of utilities have similar needs as it relates to robotic solutions. And I think there's a lot of potential for collaboration and cooperation amongst utilities. That's a model that's worked pretty well for our industry. And so I think there's a lot of potential and kind of untapped potential yet. I think we've done it better in other kind of verticals than we have in robotics, but a lot of potential for collaboration amongst utilities and robotic solutions providers. And in the meantime, I think in the near term, we need to be creative about ways, scenarios we might pilot robotic solutions that can effectively replicate real world conditions so that when we do indeed deploy them, we are sure that it works. That's kind of our take on it.
Okay. Travis, did you want to add to that?
Yeah, I would say that there's a couple of other challenges that I would bolt on to some of Josh's comments too. I think one that often comes up is cybersecurity, and that's not a concern that's specific to just the energy industry. In fact, new guidance is coming out all the time from a variety of different industries that we're working with, a lot of government agencies, even in the medical market. And I think it's key to keep that front of mind, because cybersecurity isn't something you can kind of bolt on at the end of a project. It kind of has to be integrated into the solution from the start. So that's one challenge I think that needs to be addressed. Adding on to Josh's comments, training and field testing are two areas that can't be overlooked. Oftentimes I feel that when you produce a robotic system, people look at, the hardware element's complete, but the actual integration of a robotic system into an actual use case in the field, I mean, there's still a lot of work that goes into training and testing. One of the additional point that I would say would be a potential challenge for anyone looking to deploy robotics is that or maybe one recommendation is that I would suggest that you don't start with an autonomous solution in mind for the first solution. What I mean by that is oftentimes, despite the fact that there are a lot of standards in place, and despite the fact that, power lines and things of that nature might be very consistent from instance to instance, there's still a lot of complexity when you take into account the integration of the components of the grid. So from that standpoint, I would imagine human operators will likely always need to be in the loop to have kind of that oversight. So just highlighting a couple of other additional challenges that I see.
Okay. So we have a couple of questions coming in. So please remember that you can either put them in the chat window or in the Q&A section. I've got both of those open so I can see those. It's interesting that you mentioned cybersecurity, because one of the questions that's come in is about where drones or robots are manufactured and whether or not those present new or different cybersecurity risks. So I don't know if you have a comment on that, whether the manufacturing location might make a difference.
Again, I think it goes back to, you have to look at it comprehensively. So manufacturing is certainly part of it. You have to look at where those vectors might come into play. But again, I think it just boils down to cybersecurity is a risk, just like any other variety of risks in any project. And it's something that you have to take into account on the front end of the project and not try and insert it at the 11th hour. And yeah, manufacturing, as well as kind of more or less the software architecture, is certainly something that has to be taken into account. So
how about talk a little bit about specifics about how robots have been used in disaster recovery or times of crisis? And what can we learn from some of those scenarios?
It's a great question. So I can actually highlight a couple of more recent examples where RE2 had the kind of the right technology at the right time to serve in a couple of times of crisis. So two specific examples come to mind. First of which was actually we were conducting some work, some development work through the U.S. Air Force in developing both teleoperational and autonomous robotic applique kits. And more or less what I mean by an applique kit was we were developing a robotic driver that could be dropped into either an aircraft or a large implement, so that the either an aircraft or an implement could be taken over as a robotically controlled device. Specific to the robotically controlled implement, in 2018, Hurricane Michael swept through Florida and affected a great portion of the southeastern portion of the United States. Tyndall Air Force Base was actually affected as part of that hurricane. And coincidentally, it just so happened that we were developing technology that could be directly applied in that scenario. So we were able to kind of drop in our robotic driver, teleoperate large telehandlers or wheel loaders in order to help pick up the pieces and parts that were scattered all over the place without having to expose any human operators to any danger that might have been present. Another example that actually comes to mind that occurred in 2018, and in fact the system's still operational today. We actually deployed one of our human-like dual-arm robotic systems to help remediation activities at the Fukushima Daiichi nuclear incident. This is another great example of how human-like robotic technology can be used to augment human labor where you don't want to expose human operators to a dangerous threat. Mm-hmm. And maybe jumping back to your comment around what are some of the key learnings to be shared. So first, I think preparedness and training are obviously key. In both of these examples, we had the right technology at the right time. So that was obviously critical. Additionally, in both of these scenarios, given the unstructured nature of the environment, human operators were directly in the loop. And how this ties back to, I guess, the kind of utility use case or energy industry as a whole, despite there being, again, a lot of standards in terms of how power lines are laid out, there's a lot of unique scenarios and a lot of limitations in the amount of structure that's presented to a robotic system when you compare that to, say, more of an automotive application. So given unique factors like geography or the electrical system layout, or even in examples like Josh had already alluded to, like in the case of a windstorm where there might be limbs and power lines, I would imagine that humans will likely always need to be in the loop at some level to help kind of work through those situations. And while I think a lot of the media might suggest that fully autonomous robots are here, they're off the shelf, they're ready to go. That's simply not the case. So I feel like we're a long way out from that being a reality. But jumping back to I think Josh's earlier comments, that doesn't mean we shouldn't be taking some of those proactive steps to try to make a difference today.
One of the comments that's just come in, just so you know, is that one of our guests has thanked you for your cooperation for Fukushima. So we are reaching widely today. Josh, I want to reach back and ask you a few questions, really about sort of the future use of robotics, particularly when it comes to resilience of the grid. So obviously, there's a lot of conversation about how our grid is going to survive as we grow, as we go through crisis times. So can you talk a little bit about how robots might be able to enable some of this?
Yeah, I think one of the first places to start is thinking about inspections of critical infrastructure, thinking about some of the things that we do today. We talked about storm response, ensuring that our customers are safe in the event of down power lines. I think those are maybe slightly near-term applications. And I think one of the things that's really interesting about robotics is, Travis kind of started with it at the beginning. Typically, when we say that word, we think of, maybe an R2-D2 or something like that. There are very interesting, what you might refer to as adjacencies with robotics. And I think some of those are much more interesting than kind of the conventional solution. So a couple examples of that, improving worker safety and training around AR and VR. So augmented reality, virtual reality. I think there's huge potential there. Kind of as an adjacency, you can think of other kind of wearables devices that help to maintain the safety of our employees. And I think one of the other kind of maybe further away adjacencies, but many of these robotic solutions are developing some pretty impressive levels of kind of intelligence. And if you think of grid edge devices, so your rooftop solar, your EVs, typically those devices are operating in what you might refer to as a local optimum. So that device is optimizing for the benefit and operation of that device, not always, sometimes, but not always for the system as a whole. So I think leveraging some of the intelligence and thinking about how do we enable distributed coordinated control with some of those grid edge devices. And you can imagine a future where those devices with a little bit more intelligence are able to operate in a more sort of system optimal way or a global optimal way versus a device or unit optimal way. So I think there's a lot of potential there, a lot of potential crossover there. And that's something that's exciting as well.
Travis, what do you think about all of that?
Yeah, I think Josh is spot on, and maybe a simpler way of looking at this is really robotics should just be regarded as just another tool to help people to complete their job. Granted, robotics are a highly sophisticated tool, but human-like robotics can provide the opportunity for those sorts of intervention tasks to be kind of offloaded from human operators, with the added benefit of keeping the operators obviously removed one layer from potential hazards. So really, I kind of see robotics as just a tool that can help to serve as a force multiplier, enabling operators to be more productive, perform tasks with higher quality control, and just improve operator safety. And to maybe even expand on Josh's point around technology, I think it's also prudent to acknowledge that the technology exists today where operators could potentially be centrally located such that they can dial into any number of robotic systems that might be deployed. So the obvious benefit there would be it would improve utilities' ability to respond to a potential issue, minimally getting kind of eyes on the situation, but in the future, potentially also being able to perform some corrective action without actually needing to dispatch operators. So the obvious benefit here would, in the current climate of COVID-19, would be that utility workers wouldn't necessarily have to expose themselves in order to address field assets.
And just to tack on to that, one thing there I think is important is it's there's solutions like that that Travis was referring to that allow allow us to better leverage the skills of our field workers. And the person who's an expert in X can be closer to being in more than one place and at one time by leveraging some of those technologies. So I think that benefits everyone. That benefits the worker. It puts him or her out of harm's way. It benefits the customer. I think there's doing the job right component to that. And so kind of multiple benefits all around. And I think there's a lot of potential there.
So are there specifics sort of in robotics that have enabled these new technologies?
Yeah, absolutely. That's a great point to bring up as well. So I think there's been a number of recent trends in robotics that have started to bring this to the forefront. The first trend I would say is that robots are becoming smaller, more lightweight, more power dense. So they're fitting into a lot of applications that might have complex infrastructure and tighter sort of infrastructure than where you might have previously deployed some of those larger automotive industrial robotic systems. Second is that robots are becoming more and more rugged. They can be fielded in a number of challenging environments. Construction comes to mind, agriculture comes to mind. So we're seeing a proliferation of robotic technology out in the actual world outside of like the factory floor. And then the third point, I guess, that I would make too is, and this is a specific point to the teleoperation aspect of robotics, is that we've come a long way in human-robot interfaces that have really improved the ease of use and ease of control of complex robotic systems when performing complex tasks. So, I often say the degree to which a robot is useful is proportional to the ability of the operator to control it, right? So this is another area where I think industry as a whole can leverage a lot of the R&D work that's gone into refining those human-robot control interfaces. Frankly speaking, RE Squared has spent the better part of a decade in refining our control interface to make that very easy for soldiers to basically pick up and perform a complex task with about a minute's worth of training. So I think that's also been another key enabler why we should be considering robotics now.
So another question. What related or adjacent technical developments or innovations should robotics be looking to leverage? And there's another reason I'm asking that question. Obviously, we have quite a few students on the call with us today. They're interested in how they can get involved and what things they should be thinking about.
Yeah. So I'll start with the somewhat obvious and move to the I think slightly less obvious. Machine learning, I think, is fantastic, particularly for robotic solutions that undertake repetitive tasks. And I think that's a development that can be leveraged and combined with robotics pretty effectively. Even quantum computing, if you think about autonomous vehicle applications and the sensors associated with them and the data production associated with that, you're really looking at higher levels of computing power there. But one that I personally feel really passionate about, and I think is really important for the progression of this industry, is actually design thinking. And just be frank that sometimes you see these robotic solutions and it's like, boy, that is technically sort of beautiful and is really hard for someone to use. It's really hard for a customer to do what they set out to do. And so just like what Travis was saying around, let's start when we're thinking about robotic solutions, let's start up front with a cybersecurity lens, which totally agree with, but let's try to start with a customer lens. And that's in a design lens. And I think design thinking and the sort of integration of customer empathy and a customer perspective, those two things are very related. And also doing that upfront in addition to the more traditional kind of hard science technical pieces, I really think that's going to drive our industry forward, and it's really going to drive user adoption. So if you're a design student, I do think you actually have a future in robotics. So keep at it. We need your help.
So we do have a couple of questions that are coming in. One of them is, I think, Josh, specific to utilities. It's about pilots, testing, evaluation for robotics, and even collaboration. So maybe what are some ideas around collaboration or piloting that someone could do with a utility like Duquesne Light?
Sure. So there are a variety of existing industry consortia. Apologies right now. I'm sure I'm going to miss some important ones. Just rattle a couple off that come to mind. EPRI. So that is the Electric Power Research Institute, of which we are a member. So that is a consortium of electric utilities who fund research together in a collaborative fashion. That's one. There's a variety of different labs at universities as well. So I think universities can be a big partner with this, as long in continuing to engage with some of these industry collaborative groups. And then Travis mentioned it, when you're talking about robotics developments around defense, government partners like DARPA have been a big asset in that industry. And full disclosure, I used to work at RPE, but I also, and I'm so totally biased, but I think that piece of the federal government in particular, that piece of the Department of Energy can be a good partner. So I think the challenge is, we can do a lot more of this together, and we can achieve a lot more together. I can't always promise that trying to develop a consortium for a given activity or a given pilot is easy. It is. I can't promise that it's quick, but I really do think over the long term, that's what's going to kind of generate results for us. And so, we will, and me personally, will continue to be a partner in helping folks who have good robotic solutions to try to enable those outcomes.
So we have a question that's come in about low oil prices and how those sort of, obviously we're in unprecedented times. How do we think that those might impact robotic and automation in the energy industry? So how is that going to impact some of the future innovation that we're looking for, or is it?
Travis, you want to start with that one? My
Sure.
short answer is your guess is as good as mine, but
Yeah. I don't know. I don't know that it is. I think it depends on the application. So obviously there's a lot of robotic technology that's been deployed for oil and exploration. I would imagine a lot of that will slow down amidst current events. But a lot of I think what we're talking about is really around energy delivery. So I don't know that it's as particular to the generation source. Mm-hmm. So if we're talking about getting electrical energy from, regardless if it's coming from a gas power plant, a coal power plant, some renewable source, a lot of what we're talking about, I think, has been in the context of how it gets out to customers. So I don't know that it necessarily impacts robotics and automation. I think it just shifts the focus area to other sorts of applications, be that if it's more focused on natural gas or renewable technology.
Okay. So we've talked about safety and reliability. How about energy infrastructure? So how do we deploy robotics to safeguard from a pandemic crisis? What about weather events and that kind of thing? So maybe we could talk for a minute about that. It's one of the questions that came in.
Yeah, it's a great question. And that's where, we were talking a minute ago that I think some of the most interesting applications around robotics are in adjacencies, but a lot of the core technology you imagine that's central to robotics could be applied to sort of more stationary infrastructure. Sensing, predictive maintenance, all the kind of data that is underlined and sort of enables those applications. Again, I think there's tremendous potential there, I hope there's folks out there working on sort of applying those applications to critical infrastructure, because I think there's, particularly as that infrastructure ages, there's a need for solutions that might not just be full-on capital replacement, which is often pretty expensive. So thinking about ways how we might leverage robotics and, again, adjacencies like kind of automation more broadly to make that critical infrastructure smarter and also potentially avoid the cost of full-on replacement. I think there's a lot of potential there, and something that would greatly benefit really everyone.
Yeah, and one other point I think that would be interesting too is that same robotic system that might be persistent and deployed at a static location could serve multiple roles, right? So not only could it be perceiving the world, not only could it be interacting with components to perform some sort of corrective action, it could also act as a persistent security robot from a defensive standpoint, right? So I think there's a number of different lenses that you could examine this technology through.
Okay. So we have another question that's come in that says that it's really asking about design thinking and design thinking sessions. So is there a process that happens like with a robotics company and a utility where you are going through that design system thinking kind of ideation? How does that work?
So I am not yet aware of one, but that is a fantastic idea. And in our kind of internal processes here at Duquesne, that's one of the things we're in the midst of trying to implement is, when we think about ideas and when we think about solutions, how do we integrate design thinking? How do we integrate user empathy? And so I think it's a fantastic idea to, the earlier the better, integrate those approaches. And I'm happy to share some materials offline with folks who want to learn more about it. But I think it's a great idea. We're trying to integrate it in our own internal processes and thinking about how we innovate, but doing that together with partners, particularly partners, again, who have diverse expertise, marrying the customer perspective with the mechanical engineering and robotics and automation perspective, I think is really powerful and has a lot of potential. So I love that idea, and maybe that's something we can work on soon.
Yep.
Yeah, and from a design thinking standpoint, so RE Squared typically has this process where, frankly, we've already kind of started through this discussion today, where you always start with the challenges or some of the barriers to entry first. You figure out, okay, what are the things that could go wrong, and then make sure we're incorporating those on the front end, and then also clarifying that picture around where do we want to get to long term. And then, another point I'll make a plug for CMU when we're talking about different things for people to study. I know there's the HCD group, or the Human Centered Design group, would also be another good group to pull from.
Yeah, and just one last thing here. I think this is related to and a part of design thinking, but isn't quite the same thing. It's going to sound super obvious, but I find in practice it doesn't happen as much as we all would like. Start with the end in mind. And when you start with the end in mind, you often have the customer in mind. So being crystal clear on exactly what problem are we trying to solve? And even maybe before that, do we understand what problem we think we're solving for our customer? And customer might not mean, the customer in the robotics sense might mean an employee of Duquesne, might mean an employee of a different utility. But again, that sounds really obvious. It's a one of kind of a core principle of design thinking, but I just think that's in general a best practice. Let's ask and let's spend time up front thinking about, again, what problem we're trying to solve and how we know that is indeed the problem that our customers want us to solve. And when you define that really well before you get to solutions, then you often find that you generate much more creative kind of out of the box solutions. So I think we as an industry have a tendency to jump immediately to particular technical outlines of the solutions and how brilliant it might be. But again, spending that time up front defining that problem and ensuring that is indeed the problem that the customer wants solved, I think is related to design thinking, but it's definitely something that everyone can do absent some big framework or anything like that.
So before I ask for final thoughts, I have one last question. So the final thoughts is going to be something around something that you're most hopeful about in thinking about utilities and the future of robots and how this could work. Because the question really is, we're in this unusual time, but how sustainable is this thinking when we're looking at solutions that could be for crisis when we really might want to be thinking about the long term. How sustainable is this? Can you give us an example?
Yeah, I mean, I think so. Critical infrastructure is a great example. I could, when you think about automation and robotics as it relates to critical infrastructure, you could look at that as the crisis response near term. How do we harden critical infrastructure, or how might we, for particularly stressed pieces of infrastructure, how might we deploy existing, sensor related technologies to do that? And that, in the kind of critical infrastructure piece, that is a kind of crisis response. I don't think that is inconsistent with, nor should it distract from some of the longer term things we could do. Again, just using the example of critical infrastructure. So making that infrastructure smarter with more advanced technologies, predictive maintenance around it, thinking about how we might better use it to extend its life cycle. In my mind, those approaches are not only are they not inconsistent with each other, I actually think they're complementary. So I'm not suggesting that everything we do in this space in robotics and automation is, all the kind of crisis management stuff goes well with the long term. But I think, I think with some considered thought and some analysis, we can find solutions that enable us to address a crisis, but also enable us and prepare us to start thinking about the future.
Okay. Travis?
Yeah, I guess I'll echo many of Josh's comments there. And the one thing I'll say amidst the current crisis is that I hope this is kind of used as a catalyst for change, right? Going back to I think my comments earlier regarding, either the example of Hurricane Michael cleanup, or in the context of nuclear remediation, preparedness is key, right? So the best time to have these technologies available probably would have been before this crisis even started, but the next best time is right now. So I'm hopeful that, through conversations like this, that as a community, we start to talk about investing in these technologies, starting various working groups where we might be able to work with the future in mind.
So it sounds like you just gave us your hopeful statement. So I'm going to let that sounded very hopeful. It is the time for us to be thinking about it now. Josh, do you want to add anything to that before I do our final wrap up?
Yeah, I'd say something similar, hopefully not exactly the same thing. I'm very optimistic about our potential for collaboration. And I mean that on a number of different levels as it relates to robotic solutions within the industry, kind of more directly on the topic at hand today. But I'm also excited about the potential for all these entities you see on the WebEx today are local entities. So I'm also on a more maybe immediate level, I'm also really excited about the potential for collaboration in terms of economic recovery and development. And of course, again, those two things are not only are they not mutually exclusive, collaboration around robotics and economic development. I think those two things go together. So we all feel the pain that our customers are feeling right now, and we're all, my dog's upstairs. I'm hoping it isn't barking. Everyone has, sort of situations like that. But I am, continuing to stay optimistic about the future and our opportunities for collaboration. And thanks for bringing us together, CMU and Anna.
Great. Well, I want to thank both of our guests. I'm going to not try to pivot back to a PowerPoint that shows our special thanks to Duquesne Light Company for your participation today, for RE² Robotics for helping us to sort of navigate some of these waters. We do have our next webinar will be in 2 weeks on May the 7th, and we'll be talking about utilities and infrastructure as we plan for the rest of 2020. So thank you all for joining us today. Thank you to our partners here, and I look forward to seeing you all again, hopefully in person, but also online. Thank you again.